This is problem 1-61, it's on page 42. A vacuum gauge connected to a tank reads 30 kilopascals at a location where the barometric reading is 750 millimeters of mercury. Determine the absolute pressure in the tank. Take the density of mercury to be 13,590 kilograms per cubic meter. So let's sketch this system and see what's going on. We've got a tank. And see the gauge on the tank reads 30 kilopascals of vacuum. And let's see, the barometric reading, in other words, the atmospheric pressure reading, is going to be taken from, let's just write it this way, 0.750 meters of mercury. And we're supposed to take the density of the mercury to be 13,590 kilograms per cubic meter. So the absolute pressure in the tank is how much? Well, let's start off by figuring out the atmospheric pressure. The atmospheric pressure would be equal to rho GH, just the barometric or the barometer equation. So the density of the mercury is 13,590 kilograms per cubic meter. The acceleration of gravity, 9.81 meters per second squared, and the height of the mercury column, 0.75 meters. Okay? So of course we'll end up with units of pascals, because we've got kilogram meter per second squared, that's a newton, and it's newton per square meter, which is a pascal. So let's type it in, 13,590 times 9.81 times 3/4 is 99.99, I'm going to round off there, kPa. I've gone ahead and factored out 1,000 so I can write kilopascals instead of just pascals. And so there's the atmospheric pressure. Now the vacuum pressure is just measuring how far below atmospheric pressure the tank is. So the absolute pressure in the tank, let's see, that would be equal to the atmospheric pressure less the vacuum pressure, because this vacuum pressure is just measuring down from atmospheric. Okay, so atmospheric pressure, we can round this off reasonably to 100 kilopascals. Subtract off 30 kilopascals of vacuum, and the answer is 70 kilopascals. Now, one thing to note about kilopascal units is that they don't really lend themselves to being absolute. In the English system, we have the terminology PSI, PSI-G, and PSI-A. But in SI, you've got kilopascals, and a kPa-G, a kPa-A versus a kPa just seems difficult or useless. And so nobody really uses this. Everyone uses kilopascals. So in the SI units, you have to be really careful about whether the pressure measurement you've been given is absolute, is it gauge, is it vacuum, what is it exactly? That has to be described.